What's going on YouTube? It's the Middle School Math Man back with another video for you on quadratics. So this video is just going to be an introductory video on quadratics, a little bit about them, and we're going to get into the axis of symmetry and calculating the vertex. So first of all quadratics are written in the form y equals ax squared plus bx plus c. That might look familiar from our unit on polynomials. So when quadratics are graphed, they create a U-shaped curve, which is called a parabola. So all of these quadratics, they're going to be U-shaped, which is called a parabola. So there are two types of parabolas. Sometimes they open up and sometimes they open down. Now if you notice, one of these quadratics, our a is positive and one of them, our a is negative. So if a is positive, the parabola is going to open up just like a smile. So I'm just going to draw a rough graph. So there's a parabola, it's opening up. We'll talk more about the vertex in a minute, but there is a vertex. Anytime the parabola opens up, the vertex is always at the bottom, and this is called something specific, which I'll talk about in a second. And then if a is negative, then the parabola opens down like a frown. So in the second graph, our a is negative, so it's going to open down. So again, here's another just rough graph. It's opening down. Anytime that happens, we have a point that's at the top of the graph. This dashed line I'm drawing through the vertex, this is the axis of symmetry, which we will get into here in a second. So y equals ax squared plus bx plus c. If a is positive, the parabola is going to open up. If a is negative, the parabola is going to open down. So the axis of symmetry, I'm going to write this out, excuse my handwriting. It is the vertical line. It's hard to write with the stylus. The vertical line that splits the parabola into two equal parts. So that was the dashed line that I was showing above in the graph. It goes through the vertex, and then that splits the parabola into two equal parts. Now we can solve for the axis of symmetry. The axis of symmetry, the little formula is x equals negative b over 2a. That is an important little formula there. X equals negative b over 2a. Now when the vertex is the lowest point, like when we had above, that is called a minimum. And that should make sense because if it's the lowest point on the graph, there's nothing lower than it. So that is the minimum, the lowest point. If the vertex is the highest point, if the parabola is opening down and the vertex is at the top, that is called a maximum. There's nothing greater than that point. It's a maximum. So I'm just going to run through a couple of examples real quick. So what we're going to just focus on today is given a quadratic, what is the axis of symmetry and what is the vertex? So if we look at this quadratic, our equation for the axis of symmetry was x equals negative b over 2a. Now where does the b and the a come from? Well, it comes from the problem, or it comes from the quadratic. So b is always that middle term. So we have negative b, which is 8. So we have negative 8 over 2 times a. In this example, our a is 1. So if we simplify this, negative 8 over 2 times 1, that's negative 8 over 2. So our axis of symmetry is negative 4. So my axis of symmetry, we have x equals -4. So what that means is it's going to be a line that's going through -4 on the x-axis. It's going to be going through the vertex. So what that tells us is that gives us our x value of our vertex. We need to figure out our y value. So what we're going to do is we're going to take our quadratic, y equals x squared plus 8x plus 15. Well, we just figured out that x was equal to -4, so we're going to take that -4 and we're going to plug it into the x's in our quadratic. So when I do that, I'm going to get -4 in parentheses squared, that's 16. 8 times -4 is -32. And then we have plus 15. So when we simplify this, we're going to get y equals -1. So now we figured out our x value and our y value, so that is enough information to write our vertex. So our vertex is -4, -1. And I ran out of room to do a sketch, so I'm just going to do a very brief sketch up here in the top left. So I know that my parabola is opening up because a is positive. Down here we have a vertex, which we figured out was the point -4, -1. And the axis of symmetry is just the vertical line that I'm going to draw dashed that goes through that vertex. All right, I'm going to do one more example with you. I'm going to jump to problem number 7. So again, we have x equals -b over 2a. So in this case, our b is already negative, so we have -24. So that's going to be a double negative over 2a. So when I simplify this, we're going to get 24 over -6, and then 24 over -6 is going to be -4. So we have x equals -4. Just by coincidence, it was -4 again. So again, we're going to take that -4 and we're going to plug it in to our original quadratic anytime that you see an x. So if I were to simplify this all the way down to one number, we should get y equals 6. So my vertex is going to be -4, 6. So if you're going to draw a quick sketch of this, this parabola is going to open down. And I know that it's going to open down, because a is negative, so it's going to open down like a frown. The vertex is going to be the maximum, which is the highest point. That's going to be at -4, 6. And the axis of symmetry is just a line that's going through the vertex.